Hello and welcome to the final lesson, lesson 11. We're going to take a look at our thinking question. Why is it easier to compare numbers when they are out of the same whole? It's easier because that means the pieces are the same size, and that's extremely important when we're trying to figure out how much of a whole we actually have. And I'm actually going to leave it at that because we're going to get a lot more into it today. So today with lesson 11, we're going to be adding and subtracting fractions, which is surprisingly simple as soon as you understand the concept. And it's not going to be very difficult to understand because of the lessons that we've been previously doing. So here are two different fractions. We have 3/8 and 2/5. So is it easy to compare these two fractions? Because they look to me like they're about the same size. But I can't just look at these two numbers, these two fractions, and say, oh, this one's bigger and this one's smaller, if I just look at them simply like that. And if I were to drag it over, I could maybe see. And look, this one just is a little bit larger than 3/8. It goes over by just a little bit. But that seems kind of odd because this one has more pieces, but the pieces are smaller. So it's almost impossible to really compare two different fractions with different denominators because that means the pieces are going to be different sizes. And as long as the pieces are different sizes, we can't compare them very easily at all. And that's where equivalent fractions come in handy, because if we were able to make this an equivalent fraction with the same denominator as 2/5, then that would mean that it's broken up into the same size pieces. And then we could look at the numerator, and the numerator would tell us which one has more of those pieces that are all the same size. So actually, if I were to do that with this one, so a simple one to do with this would be to get them both to have a denominator of 40. So 2 times 8 and 5 times 8 equals 16 40ths. And over here, if I do both times 5, it would be 15 40ths. So look, they're really close, but they are not exactly the same. This one is the larger fraction because there are 16 pieces out of 40 versus 15 pieces out of 40. Now it becomes even more difficult when you have two fractions with a different denominator to then add them together. How would you add pieces that when a piece of a whole is broken up into 8 pieces and this whole is broken up into 5 pieces? If you wanted to add or subtract those, that would be almost impossible. So whenever we add and subtract fractions, they always have to have the same denominator. The whole has to be broken up into the same number of pieces. So we already found out our equivalent fractions, and this one was 16 40ths, and this one was 15 40ths. So that's saying that if we had this whole circle and was all broken up into 40 pieces, so each of these would be broken up into 5 small pieces, and each of these would be broken up into 8 small pieces, and the pieces would all be the same size. That means that in the red section, I would have 16 of them, and in the green section, I would have 15 of those pieces. Now, I can add the same size pieces together, and all I have to do is add the numerator, because I'm not changing how many pieces I have. I'm just adding together how many pieces I have here and how many pieces I have here. So 16 plus 15 is 31 out of 40. So if I were to split this whole green section and this whole red section so that the pieces were the same size, we would have 31 out of 40 pieces of this whole. So here's another one. We have 1/3 and 1/4. We can't add those together. I have no idea what this fraction would be. However, if I make them have the same denominator, I will be able to add them together. Pause your video and find an equivalent fraction for both 1/3 and 1/4 so that they both have the same denominator. Pause your video and do that now. One option for equivalent fractions with the same denominator are 4/12 and 3/12. So even if I were just to represent this on the board, that would mean that 1/3 is split up into 4 pieces, and 1/4 is split up into 3 pieces, and And those are approximately all the same size. If I had drawn the lines correctly, they would all be exactly the same size. So now I can count those up and say, okay, I have 1, 2, 3, 4 twelfths, 5, 6, 7, because that was adding 3 twelfths. So now I have a total of 7 out of, if I add the whole here, there would be 12 pieces, 12. So 7 twelfths. 1/3 plus 1/4 is 7 twelfths. You're going to try this one on your own now. There's no picture, but you don't really need a picture because that would really help you anyways. So you're going to find a like denominator and find their equivalent fractions, and then you're going to add them together. Remember, you only add the numerator, because if we look back here, if we had added the denominator, and then we would have gotten 24. Well, this isn't 7 out of 24 pieces. There's only 12 in the whole, not 24. So you don't add together the denominator because that's just representing the whole. That tells you how many pieces are in the whole, and that doesn't change. What does change is how many pieces you have altogether out of that whole, and that's the numerator. So pause your video and do that now. For this one, you most likely either found a like denominator of 18 or a like denominator of 54. So either way, your answer is going to be 17/18. It's also possible that if your denominator was 54, that you got 51 over 54. Both 51 and 54 are divisible by 3, and so that's how I got to 17/18. So if you didn't figure that out, that's fine, but as long as you got one of those two answers, great. Let's do another one. Pause your video and add these two fractions. This one wasn't too hard to find like denominators. You could actually just change 1/2 to 2/4, and then you could add them together. But when you did that, you probably found that you had a larger number on top, 5/4. That means that we actually have more than one whole. That's represented here. So here's our 1/2, and then 2 quarters and 1 more quarter. So I have 1 whole and 1 quarter. So you can write it either way up top. Here's another one. Pause your video and solve this now. For this one, you should have gotten 6 over 21 plus 14 over 21 equals 20 over 21, which is nearly a whole, but not quite. Now we're going to move into subtracting fractions. This is exactly the same thing. We have to find like denominators with find equivalent fractions with like denominators, and then we subtract the numerator, and we don't do anything with our denominator. So we'll just do this one together, and then I'll have you do a couple on your own. Because as long as you know addition, then you can definitely do the subtraction. So I'm going to have you pause your video and find 2 fractions with the same denominator that are equivalent to 6/11 and 3/8. Pause your video and do that now. Here I changed the 6/11 to 48 over 88 and 3/8 to 33 over 88. And now all I have to do is subtract the numerator. So 48 minus 33 is going to be 15 over 88. So I have 15/88 left when I subtract 3/8 from 6/11. Go ahead and try this one on your own. Pause the video. There are 2 different ways that you could have gone about this. So you could have either changed it to having a denominator of 40 or a denominator of 20. But with using the denominator of 40, if you reduced your fraction, you would still get the same answer of 13/20. Do one more of these on your own now. Go ahead and pause the video. I changed my denominator to be 35, and then that meant that my equivalent fractions were 30/35 minus 21/35, and that gets me 9/35. We're going to do a couple of word problems now. So we're going to do a couple word problems now. Justin is trying to figure out if 1 cake is going to be enough for his family. He knows that his uncle and his sister always want 1/3 of the cake. His baby brother will only eat 1/12 of the cake. Justin, his aunt, his mom, and his dad will each eat 1/6 of the cake. Will 1 cake be enough? You need to be able to prove whether 1 cake is enough or not. So you're going to have to add together how much of the cake is going to be eaten if they each eat how much Justin thinks that they're going to eat. So we're going to pause your video, and I'm going to underline the numbers so that you can find them easily. So uncle and sister eat 1/3, brother eats 1/12, Justin, his aunt, his mom, and his dad each eat 1/6. All right, so pause your video and do that now. Okay, so here's what I did. I counted up how many people were eating 1/3, so 2 people, his uncle and his sister, so that's 2/3 of the cake are gone, going to them. And then the baby brother will eat 1/12, so it's just one person eating that much. And then we have 4 people, Justin, his aunt, his mom, and his dad, will all eat 1/6. So that's 4 people eating 1/6, that's 4/6. So I have 2/3 plus 1/12 plus 4/6. Now, I decided, I knew that I could get 3 to 12, and I also knew I could get 6 to 12, so I decided that I'm going to do 12 as my denominator. Now, that means that 2/3 is equivalent to 8/12, 1/12 is equivalent to 1/12, and 4/6 is equivalent to 8/12. When I add that together, 8 plus 1 plus 8 is 17/12. Now, 17 is a larger number than 12, so if a cake can be cut into 12 pieces, and I need 17 pieces, then one cake is not going to be enough. And here's your thinking question. In which kinds of situations do you think you'd have to add or subtract fractions in real life? Now, since this is the last video, there's actually not going to be an answer, but you can definitely be thinking about it, and then when you come up with a time when you can use adding and subtracting fractions, do it so that you can practice. All right? Great job with all of these videos and for sticking it out. I'm very proud of all the work that you've put in. Thank you, bye.